Throughout known history, weather-related hazards or disasters like cyclones have been responsible for huge losses of lives and property. Hence, their prediction by the use of modern technology and human knowledge becomes imperative for saving human lives over this region. The understanding of these cyclones and their prediction becomes even more imperative for a country like India, whose coastal districts face the maximum consequences of this high-impact weather event. In the last 300 years, out of the total number of cyclones developing on the globe, almost 75% of them, which have caused a death toll of more than 5,000 people, have occurred in India, especially the Bay of Bengal. October 29, 1999, a super cyclone with wind speed of 260 km/h struck the Odisha coast, bringing unforeseen devastation upon the state. Killing almost 10,000 people and destroying property worth more than 1,000 crores.
On the monitoring aspects, well, we had satellites that only gave us imageries of the cyclones, but we did not have other parameters to characterize ocean conditions and the cyclone itself, both its physical as well as dynamic parameters.
The computing system was also limited, and the number of numerical weather prediction guidance to the forecaster were also limited. As a result, not only the lead period of the forecast was limited to 24 hours, but also the accuracy and consistency of the forecast was not quite good at that time.
The tragedy shook up the country and shifted the focus to IMD. It was beyond doubt that the outdated technology being used for cyclone prediction had proved to be the biggest hurdle in India's forecasting abilities. 14 years later, a similarly intense cyclone, Cyclone, struck the Odisha coast again, this time near Gopalpur on 12th October 2013. However, this time the scenario had completely changed. The state authorities had received the most accurate early warning 5 days in advance, and they had taken the required action on time, restricting the death toll to just 21 people.
If you have to have a very effective system of humanitarian assistance, perhaps you not only give a state of preparedness to yourself, but also you need to be bolstered, you need to be helped by early warning system. And of late, our institutions have become very, very robust, they have become very scientific, and they have become very accurate and predictable. So that was the reason why we successfully conducted our operations in Cyclone Cyclone. People have been alerted to get evacuated. People have been believing those signals and warnings.
Some agencies predicted the further intensification of to about 300 km/h wind speed at the time of landfall. It was creating panic among the public and also among the disaster managers. So therefore, there was a tremendous pressure on the forecasters either to change the forecast or to be consistent with the forecast given by them.
IMD persisted with their forecast, displaying confidence and nerve during a time of immense pressure, while other agencies showed different predictions.
Two screens from time to time I used to monitor the prediction given by IMD, as well as I used to monitor it through US Navy, because I had still doubt because I myself was a collector. I knew how we suffered because of the super cyclone in '99, but at the end of the day, the IMD's prediction was much more accurate.
I can remember this US military or the US Navy sites. They predicted the wind speed will be around 280 plus. But IMD stuck to 220 to 230, so we got only that much speed only. So I hope we'll keep on relying on IMD sites only.
Not only had IMD saved thousands of lives, early warning system also helped in saving the government exchequer almost 500 crores.
I followed the international meteorologist Eric Holthaus, because he was also vigorously following it and all that. IMD was closer home. The international meteorologist was a little far from the fact. That's when you know that they have done a pretty accurate job. The sense of skepticism was there because you have seen 1999, but the energy could be seen. They were absolutely on their toes, they left nothing to chance.
वैसे चले जाने से आदमी लोग सब मर जाने वाला था। वहाँ गाछ फूछ फट के सब कुछ छिन छतर हो जाना था। यहाँ जो था ऐसे बच के कुछ बच गया, नहीं तो वहाँ जाने सब आदमी मर जाता।
हम दुकान में आने जाएंगे, स्कूल में जाएगा ना कि हम सब मिलेगा अनन के तूफान हुआ कि इधर में आएगा ना दुकान के कारण सब बंगे हो गया ना कि हम के नुकसान है ना दुकान में नुकसान हो गया.
This is very significant given the ferocity of the cyclone and the fear it had generated, especially among foreign meteorologists who were predicting absolutely the worst. The Indian Met Department's predictions for once was spot on.
The Met Department was spot on in its predictions, far more accurate than Western observers who felt that India was downplaying the potential danger of the cyclone.
रात आए तूफान को हिंदुस्तान ने वाकई हरा दिया और वो इसीलिए क्योंकि हिंदुस्तान तैयारी करके बैठा था.
मेट्रोलॉजिकल डिपार्टमेंट ने बहुत एक्यूरेट इंफॉर्मेशन दिया है और आप तो जानते हैं 9 लाख लोग इवैक्यूएट थे 36 आवर्स में. ये बहुत भारी काम है.
इस साइक्लोन में मौसम विभाग ने टेक्नोलॉजी का बखूबी उपयोग किया और 6 तारीख से ही ये संकेत दे दिए गए थे. जो अनुमान थे उतनी वेलोसिटी रही, जो दिशा थी अनुमानित वही दिशा रही, जो अनुमानित टाइम था वही टाइम रहा.
While media at home heaped praises at the agency for saving thousands of lives, WMO and World Bank openly acknowledged its role in averting a disaster of this scale. For the first time, IMD received a national award from Indian Institute of Management for effectively averting a disaster. India Meteorological Department then went on to make equally accurate predictions during other cyclones, including Hudhud, which hit Visakhapatnam in 2014. Further cementing its credibility both nationally and internationally. Phylin and Hudhud are not isolated successes. There has been continuous improvement in cyclone forecasting in recent years. The modernized early warning system of IMD includes observations, monitoring, analysis, numerical modeling, forecasting, and warning dissemination.
There is a significant improvement in the monitoring aspects. On the front of data utilization, we have made significant progress, and because it is through data we define the initial conditions. So our skill for defining the initial condition is better now. And the third aspect is the models. We have made significant improvement in numerical models, and not only the global models or the regional models, but the models which are targeting the prediction of cyclones.
Before we proceed to understand the modernization of IMD's early warning system, critical to Phylin's success story, let us first understand the characteristics of a tropical cyclone. Tropical cyclones develop over large bodies of relatively warm tropical water. The word tropical refers to the geographical origin of these systems, specifically over the tropical seas. A tropical cyclone is known as hurricane over North Atlantic, typhoon in North Pacific, and cyclone over Indian Ocean. A tropical cyclone can be described as a compact air mass rotating clockwise in southern hemisphere and anti-clockwise in northern hemisphere with wind speed of at least 62 km/h around a central region of low atmospheric pressure. There are mainly two cyclone seasons in India. The first one is the pre-monsoon season from April to June. The other is the post-monsoon season from October to December. Out of every 5 cyclones, 4 occur over the Bay of Bengal and 1 over the Arabian Sea. Out of every 5 cyclones, 2 to 3 become severe and 1 to 2 become very severe cyclones. Based on the pressure drop and maximum sustained surface wind, the tropical cyclones in the North Indian Ocean basin are divided into 5 categories, namely cyclonic storm, severe cyclonic storm, very severe cyclonic storm, extremely severe cyclonic storm, and lastly, a super cyclone. A mature tropical cyclone consists of an eye, which is the center of cyclone. This could be 10 to 50 kilometers in diameter. Surrounding the eye is a thick mass of clouds of around 10 to 100 kilometers, known as eye wall region. This region is the most dangerous part of the cyclone, where wind speed could go up to 250 kilometers per hour. As we move away from the wall cloud region, the clouds trail away from the eye wall region in a spiral. This area is known as the rain band region also. Cyclones, a multi-hazard event, which cause damage through rainfall occurring before the cyclone makes landfall, then the heavy winds of the cyclone. And lastly, abnormal rise in sea levels, also known as a storm surge. The collapse of buildings, falling trees, flying debris, electrocution, floods, aircraft accidents, and disease from contaminated food and water in the post-cyclone period are some of the effects of these cyclones. They are not only responsible for the large number of deaths of people living near the coast, but also register many far-reaching consequences for the livelihoods and the general well-being of people as well, causing severe damage to infrastructure and taking the economy of a state back by several years. There are 96 cyclone-prone districts in the country. The process of the forecast of these cyclones begins with observational data, which is acquired from different sources to determine the current location and intensity. The center of a cyclone is the center of the lowest pressure or of the anti-clockwise circulation of wind at surface level. This is because the intensity of a cyclone can be determined on the basis of the pressure drop at center or the maximum sustained wind speed due to the cyclone. Near the center of cyclone, sharp fall in pressure is registered. Space-based observations are the most important tools for any early indications of a cyclone, since cyclones develop over the sea and satellite is the best tool for detecting it. For this purpose, IMD uses 2 kinds of satellites, the geostationary and the polar orbiting satellite. The geostationary satellite gives images every 30 minutes, enabling scientists to monitor every half-hourly change in position, intensity and structure of cyclone. There are currently 3 such satellites, Kalpana 1, INSAT 3A and INSAT 3D, made and launched by the Indian Space Research Organization. The intensity of the tropical cyclone is estimated with the help of the visual pattern that it demonstrates as visible in the satellite images. This technique is called the Vorak technique, where the estimated intensity of a tropical cyclone is put into a scale of 1 to 8. So T 1.0 is a low pressure area, 1.5 is depression, 2.0 deep depression, 2.5 cyclonic storm, 3.5 severe cyclonic storm, 4.0 very severe cyclonic storm, 5.0 extremely severe cyclonic storm, and 6.5 super cyclonic storm. India Meteorological Department acquires data from American NOAA and European polar orbiting satellites. These products help in better understanding of cyclones and also provides surface wind over the oceanic region.
So it sees different area. So you cannot have the same area coverage by one polar orbiting satellite. While geosynchronous, every time it sees the same area. So both are worldwide. They are used in combination.
When the cyclone comes closer to the coast, within the radar range, the radar observations are given priority to determine the genesis, location, and intensity of the cyclone. IMD has been using analog radar technology for many years, but since 2002, it has acquired the Doppler radar as well. Currently, there are 24 Doppler weather radars that provide imageries in every 10 minutes and hence structure of cyclone.
So it is able to provide the vertical structure of the cyclone, that how tall is the cyclone is, because it is another parameter for intensity of cyclone. Moreover, the diameter of the eye is another important parameter which can be seen very clearly from the Doppler weather radar. So when the Doppler radar is watching from a distance of say 200-300 kilometers, it is giving a very good information regarding its prediction for its movement, for its intensity, for storm surge, and for what kind of the destruction potential is there. Earlier only the information about the precipitation was available and about the cloud or system. Now not only the precipitation quantitatively, that this much of the rainfall is expected, say around 200 kilometers per hour winds are available in the particular system, like filing. So Doppler radar can provide those informations which were not available earlier.
As the cyclone moves closer to the coast, they can be observed through coastal observatories, automated weather stations, and buoys stationed at sea. India has a vast network of manned observatories and automatic weather stations. The data which are received from the different sources are received at the National Meteorological Telecommunications Center at New Delhi and then disseminated to different user groups. Currently, this data is available to a forecaster within 10 minutes of observations, unlike 3 hours or more taken 10 years back.
Nationally, we have total 6 automatic message switching systems installed at 6 airports.
All this meteorological data is vast and complex in nature, as it is collected frequently throughout the globe. This data is processed with the help of a high-power computing system. Once processed, this observational data is put through a numerical weather prediction model to get a forecast. These results or forecasts may differ from model to model, as each of them have different characteristics like data used, method of data assimilation, region of modeling, physics used in the model, and also the resolution. The forecasts generated by the different models are available in binary format, which are converted into pictorial or graphic format through the use of softwares. This makes it easy for a forecaster to be able to see the predictions at one glance. This forecast is available every 6 hours up to 5 days. After determining the initial location and intensity, it is attempted to forecast the official track and intensity by comparing different model forecasts. The numerical model forecasts may differ from each other. Hence, the forecaster utilizes the experience, expertise, and the decision support system to arrive at final decision. Considering recent development in prediction capability, IMD introduced the Objective Cyclone Track Forecast, valid for next 72 hours in 2009 and up to 120 hours in 2013. Heavy rainfall due to cyclone is monitored with satellite and radar, automatic weather station, and ARG-based rainfall and satellite rain gauge merged rainfall dataset. The storm surge is monitored with the help of tide gauges and coastal buoys. The forecast of storm surge is issued by IMD based on IMD Nomogram Ghosh model, IIT Delhi model and INCOIS Hyderabad model.
In case of tropical cyclones, a forecaster initially looks at each and every model forecast to find out which model best suits to the initial condition of the today. If a model has picked up the initial condition of today, then it can be assumed that it can provide the better forecast for tomorrow or day after tomorrow.
In the second approach, a forecaster depends on his expertise in choosing the best model based on past experiences. In case the best model is differing in the initial conditions of today, those conditions are adjusted statistically. The consensus is built up from the different model results. For example, through the multi-model ensemble technique for predicting cyclone track, or a dynamical statistical model technique for predicting its intensity. The single model based ensemble prediction system, which is also referred to for estimating the strike probability of a cyclone near a coast.
So no model is perfect, as I mentioned, and also no model is consistent for all cyclones. That is also important. So that's why we need that ensemble.
It is important to note here that the final forecast which is arrived at is the result of both scientific techniques as well as human expertise. The value of either cannot be underestimated when discussing the accuracy of weather forecasts. After the forecaster has made the final decision, the forecast is issued to the public and specific user groups in the form of textual or graphic bulletins. These bulletins consist of all relevant information about current status like location and intensity, expected cyclone landfall point in time, expected adverse weather like heavy rainfall, gale wind and storm surge, area to be affected, damage expected and action suggested. They are issued in every 3 hours. These bulletins are issued separately for different users like general public, fishermen, farmers, coastal authorities, disaster managers, etc. Bulletins are disseminated through various means including website and other electronic media like emails, SMSs and fax, as well as social media like Facebook and Twitter. Along with the daily press release, press conferences are also organized to trigger the general public and disaster managers for suitable action. The state and central governments make required arrangements in case people need to be informed or evacuated and shifted to cyclone shelters.
National Crisis Management Committee. This is headed by the Cabinet Secretary. As soon as there is a warning for this, and we do not wait up to the actual landfall of cyclone. Actually, 2 days, 3 days prior to it, the meeting of NCMC takes